Okay friends, this is the overview of variation of damping ratio in a control system. What is the system response? We first consider that when zeta means damping ratio. When damping ratio is equal to 0, that means the poles are located at pure imaginary poles. The oscillations was pure oscillatory. It is called as a undamped. Okay, poles are pure imaginary. It is also called as a marginally stable. What is meant by marginally stable? When the input value is matches to the output, it is a stable. In this way, we have this is our input value. It is behind the input. That's why it is called as a marginally stable. It is not a stable, but it is oscillating throughout the time at indefinite time. That's why it's called as a marginally stable. It was undamped. In undamped oscillation, there is no stable state. Next one was when zeta is in between 0 to 1. In this case, the poles are complex conjugate. It was a stable system. In this case, the response is oscillatory and reaches to steady state. In this case, output equation was exponential form into sine wave. The amplitude of sine wave with respect to reduces to time. Why? Because it is a multiplication of exponential form. Is a e power minus alpha t into sine of omega dt. That's why it is reduces the amplitude of the sine wave. The poles are complex conjugate. Next one was when eta reaches to 1. When zeta reaches to 1, the poles are negative real and equal. That there are two poles are negative real and equal. There are wn comma wn. These are poles. It is located in same pole. These are two poles. The poles are represented as cross. In this case, the response reaches to the without oscillations. It reaches to steady state. Okay, it is called as a critically damped. We discussed in the critically damped in previous lecture. It is stable. Poles are negative real and equal. Okay, when eta reaches to 1. So we consider the maximum value of eta is 1. It was a critically damped. When the next case was when eta greater than the 1. In this case, the response of output was steady state to reaches, but the difference between critically damped and over damped means in this case the response is reaches to steady state was lesser time. In this case, the response reaches steady state is more than the critically damped. That's why it is called as a over damped. In this case, there is no oscillatory, or it is also called as a non-oscillatory response. In this case, the poles are negative, real, and unequal. Okay, it is also considered a stable system. Thank you for watching. Please do like and subscribe the channel.